Here we have another challenge question that's going a little beyond what we learned in the 2.2b lesson. Confirm that, and here we're given a line, minus 620 plus t32 negative 1 is a solution to the system of linear equations presented here. And then they're being asked to interpret this geometrically. Well, we already recognize that this is a line, and that these are some planes, so that's introducing some geometry. We can do a little bit better. But, well, how do we show that something is a solution to a system of linear equations? In the past, when it was just a point, you plug the point in for x1, x2, x3, and make sure that, yeah, both sides of the equation are equal to 10 or minus 14. But now we have a whole line here. So what can we do? Well, we want to still talk about the x1 component or x1 coordinate of points on that line. So what we're going to do first is express our line a little more compactly by simplifying the expression here. Minus 6 plus 3t's, 2 plus 2t's, and 0 plus negative 1t is just negative t. So there we go. And now this gives me x1 for any point on the line. This expression would give me a corresponding x2. This gives me an x3. For any choice of my parameter t, I get a point on the line. For a line to be on the plane, every point on that line must be on the plane. So now let's plug these expressions in, not unlike what we did when we were trying to find points of intersection. Okay? So we'll plug that into each one of these planes. So the first one, minus x1, but it's really going to be minus 6 plus 3t, plus 2x2, except there is no x2 anymore, it's 2 plus 2t, plus x3, and we should get a value of 10. Just 10. So all the t's should probably cancel out. So 6 minus 3t here. 2 and 2 is 4. 2 and 2 is 4t. And then plus negative t is really just going to be minus t. Now the 6 and the 4 here combined to be 10. 4t's minus 3t's would leave me with 1t. Then you minus yet another t, and all the t's vanish, which is what we wanted. And we get 10 equals 10. Left-hand side equals right-hand side. That's great. So this line is on the plane, that first plane, because no matter what value t is, the equation still satisfies the plane. All right, let's try the other one. So it's 2x1, except there is no x1 anymore. It's minus 6 plus 3t, I believe. Just check. Then in place of the x2, we have 2 plus 2t. And then 4x3. But x3 was just negative t. And we should get minus 14 when all is said and done. Okay, well, simplify the expression on the left. Minus 12 plus 6t minus 2 minus 2t, and then 4 times negative t is going to be negative 4t. There we go. 6t minus 2t minus 4 more t's gets rid of all the t's. And then minus 12, subtract another 2, really is minus 14. So yes, the line is on both planes. Okay, we have verified that. So the line is on both planes. It's a solution to the whole system. And the way we can think about this geometrically, we've got two planes here. We can think about this line that we were given, negative 6, 2, 0 plus t, 3, 2, negative 1. That's just telling us the line of intersection when these two sort of sheets of paper collide. That's this line here. So there we go. Now that, of course, it was a challenge question. It's a little beyond what we're doing right now, but it gets you thinking. And if you understood that, or if you were able to do that confirmation on your own, then you're really following along with the material, and that's great.